Thank you for joining my talk. Today we are going to talk about Go and Microservices at SoundCloud. The name of my talk is A Tale of Go and Microservices. So we are going to start by introducing myself. Who am I? And we will share some context on developing software, and then we will see the tools of the trade. What do I use? We will introduce the Go programming language, and we will see how I relate to it and how we introduce it in SoundCloud. And then we're going to tie everything up in the microservice part of the talk, where we will define what is the definition of microservices, how do we use them in SoundCloud, information on the bounded context, and then how do we use them with Go. So, myself, I was born in Italy, in Rome, and I am doing this job for 12 years. I worked with different technology like Python, Perl. I've been full stack developer. And then I also worked a lot with SQL Server. 5 years ago, something happened, and because of mechanical keyboards, I moved to Berlin. And since then, I started joining the Go meetup scene in Berlin, and at some point, I developed an hack for the Nintendo DS with Go. Someone from SoundCloud was there, noticed me, he was interested in my talk, and then he contacted me, and then 3 years ago, I was hired by SoundCloud. So Go started as a side interest, and then it landed me in SoundCloud. So in SoundCloud, I use Go every day. We do microservices, so they are a big part of our work. We use cloud services as well. My team is called the playback team, and is responsible for many things that happen when you press the play button. So we deal with transcoding, streaming APIs, streaming protocols, maintaining the streaming infrastructure, so CDN, storage, cloud, etc. And we also have persons working on the native players on mobile platform and the web players. So let's share some context. There is a very nice talk by this guy, Rich Ike. The talk is simple, made easy, and he defined a set of questions. And the answer to this question is what's matter in writing software, not really the look of it, the experience, or writing the code. That's important for us, but as a developer, but not in order to create good software. So what matter is answering to this question, and this question we will see it's really something that we will come to them in other part of the talk. So, during my career, I mostly use Terminal, doing my development in Vim or Emacs, big user of Git. And then since I work in SoundCloud with more people than I ever worked with, discussion are a super important tool because you want to discuss things before realizing them. You also want to understand, have someone solve this problem earlier on. So you want to leverage the company knowledge. Google Docs, another very important tool. It's very important to have a common tool to have discussion, and it's very effective. So let's have a look at Go now. Go, the legend one that Go was 20% project of some Google engineers. And these engineers were Rob Pike, Ken Thompson, and Russ Cox, and others. But these people, they worked on Unix, they worked on other cool technology like Unicode, they worked on Plan9, and they did incredible good work. So around 2007, they were discussing why it's so painful to write software at scale at Google, to write large distributed system. And they found some point they were agree on, like for example, building time was incredibly high. So you write something, and to build it, it takes 20, 40 even hours. And then also this language, Python or C++, for example, in this language, doing concurrency feel like something that have been added on to the language later on. So they wanted to build a language where building time was reduced to the minimum, and where concurrency is something that was from the beginning in the language. And that's how they come with Go, the first release at the end of 2009. It is compiled, statically typed, and give you automatic memory management through garbage collection. So Rob Pike in a Go blog article say, oh, Go is efficient, scalable, and productive. But then some programmer can find this fun to work in Go, but some can find this, it's unimaginative, it's boring. And in the article, they explain why it's okay, why these are not contradictory positions. I found this really cool because it gives you the idea that they didn't want to really create something breakthrough or something which can do many things. No, they had a specific problem and they built an efficient engineering tool to fix the problem. Myself, what do I think about Go? I think that is very opinionated, and for some people this is bad, but for me it's very good, because there is less time spent arguing about things, because there are very strong idioms, and the language, even in some case, give you only one way to do certain things. So when you, for example, are reviewing code, less time is spent arguing about things that don't really matter, like code style or, I don't know. So, for example, code formatting is something that is automatic in Go. There is a tool that makes this possible. So when you review pull requests, usually there is no discussion on how many space versus tab, or I don't know, indentation, and so on. But there is include. What does it mean? It means that the standard library is incredibly comprehensive and of very high quality. You usually don't need framework in Go. You can just start. You use the HTTP server, HTTP client, and you can do many amazing things. There is even earlier support for HTTP 2 from many years. You have JSON and so on. So in SoundCloud, SoundCloud at some point, as we will see later, we wanted to move from a Ruby on Rails monolith into microservices. And as a requisite, we needed to have a platform as a service running in SoundCloud. Now we were a big fan of Heroku, so some developers say, why not rewrite Heroku in Go? And this is what they did. They wrote what is called Bazooka, which for some years have been also open sourced, but eventually we ended up now these days using Kubernetes by Google, which is also written in Go. Prometheus is an excellent monitoring system and time series database. It was born in SoundCloud. We had the problem of how do we monitor these microservices, so some very smart engineers started working on it, it took off, and now it's an open source project. Microservices. They are one of these buzzwords we like to use in IT, and it's really a different flavor of service-oriented architecture, and the word started trending around 2012, 2014, and this is where some company like Netflix, eBay, or Spotify, SoundCloud, they started blogging about it, their experience. Now, it's a kind of architecture that leverage some concept of domain-driven design, and it's trying to solve problem which root into how do we scale our technology, but also how do we scale the process to produce software, to release feature. Are you ready for microservices? It's not, there is no easy answer because there are many hard problems to solve before even considering them. So you have to understand domain-driven design, because otherwise you will get lost in the sheer amount of possibility you have. You need to be able to deploy different stacks. You can write microservices using the JVM, using Go, Ruby, whatever, but you need to deploy them. You need to monitor all these services, and then you need to understand the problem of asynchronous versus synchronous communication, the problem of eventual consistency, and then you need also able to scale your network. Things like load balancing, they assume a different flavor with microservices. You may want to do different things and so on. The bounded context is a very important concept of domain-driven design, and I personally think that microservices are leveraging on it. It took me a long time to understand the word itself, but a very good example is, imagine you have your big Ruby application, and you imagine you want to represent the schema for a truck. And now, wow, Over 1 year, the track has grown so big that we have more than 60 columns. So it's not only a problem of this can get us in trouble with the database itself, but also when you onboard new people that have to learn to release feature, or possibly they can understand the meaning of all these 60 fields. So, so what you want to do, for example, is that you want to say, okay, I have a streaming team, and the streaming team will use its own streaming track model, which is basically extracting a part of some of these fields, or even reinventing them for their own purpose. And in this example, we see that from more than 60, now we just need 5 of them. So working then on the streaming technologies, it's easier. You don't need to know all this huge amount of information. And that's key point of microservices. There is the definition that it's something where things fit into your mind. You know, if you have a huge monolith, you have a huge domain. But if you chunk it in smaller ones, it's easier to reason about them. How we move it to microservices in SoundCloud. So that's a good, in my opinion, view of the things. You have a big, fat Ruby on Rails application, and then you slowly start add the smaller, lean, and faster microservices. So this is an example. You see we have a public API and the different user experience, like, I don't know, mobile, third parties, or the website are using this public API. And then everything use a single MySQL database. At some point, the problem was, okay, as I said, the domain is getting too big, it's too expensive to onboard people on this thing, it's too risky to do deployment because one small change can affect many other components. So we started investigating microservices, and we ended up implementing some of our features into them, like search, for example, or like activities. So imagine your social kind of features. So in this situation now, we still have the public API, but now we have also an internal API, which is only used by microservices to communicate with the MySQL, which is still the authority for many information, but we were able to extract, for example, information about search into their own microservice database. So you don't only extract code, you also extract part of the infrastructure. Now there was another problem, because if you see, we just have one public API, but at some point mobile got incredibly important, and on mobile you want to leverage certain aspects in order to, for example, maximize battery life or network reliability and so on. So it was necessary for us to provide for each different user experience a backend, and this approach is called backend for frontend, or BFF. And this is, I think they do something similar in Netflix, and they call it Zool. But this is possible because of microservices. This leverage microservices and give you the ability to fine-tune the API for each user experience. Interesting thing is that, okay, now you convinced me I want to start my company and I want to immediately use microservices. Well, that's wrong, because it has been observed that many companies started with microservices, but they were not going fast. Actually, they were going slower than companies starting with a monolith. Why? There is what is called the microservice premium, which is this phase in which having a monolith make development easier, because you don't have to concern about the problem we have seen before, monitoring of many services, network performance when you have many services, and so on. So if you see the graph, you will see that microservices are really a good idea when your business has been validated, when your technology is okay. It supported the business, now the business is grown up, and we need to move on. But if you start with microservices, you have to be aware that you may incur in this reduced productivity. This is from a series of articles by Martin Fowler. He writes excellent blog article on its blog about the topic. And then finally, this quote by Sam Newman, who also is very active in the microservice area. It just connects us to those questions I said at the beginning that are what matter in software. So So microservices are just mean to an end. It's not something, yeah, I want to be cool, I want to do microservices. No. You do microservices if you need microservices. What I like about them, I work with them now, it's 3 years. We've been through very rough time where my team was of the size of one person, me. So I had to learn how I can fix bugs, keep the system running, and also work on features. So in this experience, I noticed that that microservices are giving me confidence because I can experiment with different technology for different microservices. I can start something in Clojure, or I can use Go, go back to Java, whatever. They promote ownership because I feel that I own this service because I fully understand it, because its size is smaller compared to the huge monolith. And then dependency are less, and also they are better understood because when you isolate part of your, when you isolate feature, you don't need all the dependency every time. There is the isolation, so your service is running as a single entity, and you can track metrics better, you can optimize for specific performance, and then you can isolate failure, and this is very important because you can recover from failure in different way for each service. They are developer friendly. The bounded context makes your model understandable, and then new recruit can be onboarded faster. What I don't like, well, of course, it's not a silver bullet. It's not something that solves all the problems. There are still problems. For example, the autonomy they give to you require a very strong lead, because the lead now has to understand domain-driven design, and the lead need to keep coherence with the other part of the infrastructure. It is an hard job to onboard everyone on this concept, and it can promote the isolation and disconnection from the product, because now you're working on your own feature, you may spend months on them, and maybe you forget what other things are happening around you. Confusion, sometimes team move, change, but services are there and they are not owned by anyone anymore, so who owns what? And you need to create a special team which deal with the risk of having orphaned microservices. And then there is the concept of an ubiquitous language, it's very hard to pronounce, and which in theory should be a constant effort. You should build a dictionary of words that make possible for all the subdomain to be understood. And this usually we are very bad in doing this. We don't have time, so in the end people talk about the same thing but with different terms. This creates confusion. There is the aspect of decentralization, because now we rely on the name of these microservices, and naming is one of the most complicated matter. In SoundCloud, we have service called Banana, and when someone is paged at night, hey, Banana is broken. Oh, what does it mean? So then there is the problem again of dependency on dependency management. Yes, they are less, they are better understood, but if I want to update them, it can be problematic, especially with certain languages. So let's see now, let's take together the microservices, Go, and see how we do it in SoundCloud. We will see an example of project layout. So we will see an example of how we structure our source code, and then we will see how we configure deployments, and in the end we will also see how we handle dependency, which usually we do the very brutal approach of freezing our dependency using the Go vendor approach. In SoundCloud, so each team is responsible for mostly the entire life cycle of the service. So you have to develop it, test it, deploy it, maintain it. The company is offering a series of tools to developer written in Go, which make possible to easily do these steps. And they're also maintaining the infrastructure. They maintain the Kubernetes cluster, and if you have any other resources, like for example MySQL, there is a team that maintains the MySQL database. Let's see, we want to do backup of media, and this is how we organize a project. We try to have not too much noise, so we isolate everything that can be shared, that can be a reusable Go package in a lib folder. So in Go you have this thing that if a package is named main, it can only be built, it cannot be shared. So in this case, these are for shareable components. Then we have a command. Command is for the final build, the executables. And so usually we may have many of them. In this case, we have a backup server, and then we have some tools which use the libraries. This part is not shareable. It's completely isolated. Then we have a config folder, which is platform specific. In some case, can contain cloud provider configuration, I don't know, CloudFormation templates. In Kubernetes case, they will contain a pod YAML file, which defines certain aspect of how do you want to run your service, like the resource quota, definition of ports, or for example, how service discovery, if a service is unresponsive or if a service is dead. So we also have environment configuration, because we can create different environments for services, meaning that we can have a staging configuration, test configuration, production, and so on. Then we have this manifest file is used for something called the human registry. It's a concept that you want to implement something that scrape these microservices and get information from them, from the repository. So for example, in this case, you see these are some service my team own. And if you go in the detail, you will see that you have many things, but you also have many important things like, okay, what are the rollout, what are the features we can enable, the repository, link to dashboard, link to runbook, which are what contain the emergency procedure, and so on. So it makes easy to reason about what a service is. The makefile target, I will go over this very quickly. It's we use makefile as an interface to build, so you can build your project on your own laptop, basically, or in the CI. But there is the concept is that you use tool provided by the continuous deployment tool, and the steps basically are the assemble step, where you start to creating a directory which will contain all the things needed to run the project on the target platform. Package, take this directory and create either a Docker image or a Debian file, depending on where you're going to deploy to. Then you have the publish step. This upload this image or Debian file to its appropriate repository, remote repository, registry. And then the publish deploy step is it prepare a deployment script, so you can configure, for example, where this service will be available. Is it going to be available through service discovery, or is it going to be available through a load balancer, and so on. And then finally, you can configure tags, so you can have, for example, a canary release, you can have staging, and so on. Deploy is what take your service, your artifact, and deploy to the specified number of replicas. And then promote, say, okay, this service has been running stable, and now it can be considered good for being integrated to other services. Testing, so okay, unit testing, all these things, these are our responsibility. Is not really interesting at this point. What is interesting is that we are able with Go to compile a test into its own binary file, and then we can execute it. The test is parameterized, so we can say, okay, we deployed the HTTP app, and now we want to test some requests on it. And if the tests are passing, then the deploy can go on. Otherwise, we roll back. So we can do this both with live traffic, or we can do this by having an instance that is not listening for any live traffic, but we can fake a request and inspect the response. So monitoring, we use Prometheus, of course, and Prometheus is working in this way. Each team has its own Prometheus server. We manage it with configuration management, for which you are responsible for your configuration. And you define a target. Each target is a service. You say, what is the service discovery address of this service? And then Prometheus do scraping at a regular interval. So you will have, so it's doing this in a pool approach. So it connects to each instance and pull the data. This is an example of how we integrate Prometheus in our code. You include the library, and then you can define as global variable, they are thread safe, the single metric you want. You have counter, histogram, and so on. and then you register this with the Prometheus registry. And then finally, you integrate it in your code, and you can, in this case, increase an error counter if something bad happens. And you can even pass labels, value to the labels. So then in the end, you expose these metrics through HTTP, and this is what it looks like when you go to this endpoint, when the script the endpoint. It exposes both your metrics and some platform-specific information. In case of Go, for example, you have number of Go routine, garbage collection direction, and so on. Then finally, you can plot on Grafana, for example, and then you can also configure alerting through Prometheus roles. So you have one server for each team, but then there is one big alert manager server, which is another Prometheus product. And again, you configure this with configuration management, and when a rule is matched, for example, latency is exceeding a threshold, you get an alert. And then the alert can be customized, including, for example, a link to the dashboard, and it can be including a link to a runbook and so on. So we don't have much time, but I will try to tell you what I like about microservices and Go combination. I think it is particularly effective because it's compiled, so you have very small build, very fast to deploy. They don't saturate your network when they get downloaded to each single instance. Fast startup time, you can leverage this. You can have services that die because they are hitting their memory limit. It's fine. It will take less than 1 second to restart them, and then you in general faster deploys. Vendoring, freezing is bad, but it's also good. Why is bad? Because of course you then need to update each single service, each single dependency, but then you have perfectly reproducible build. And there is no need for a central repository. Libraries, everything is there. You name something, there is MySQL, Cassandra, Kafka, so on. Toolchain is great. You have many nice tools. You can check for race condition. You can export performance analysis using the pproof format. You can even inspect this while the service is running. And what I don't like, vendoring, again, I say freezing is bad, versioning how you do it, and then go get what is the purpose of it right now. See, interoperability is very important for us, but it's extremely hard to find good documentation. Plus, when you embed complex things, it can really get nasty. I mean, build time increase and your tool are not working properly anymore. With this, I conclude, and I invite you to join the SoundCloud Backstage blog, where you'll find many information, including the 3-chapter story of how we moved to microservices, and in the end, there are even some conclusion like, did they help us, yes or no, and what didn't work well, and so on. Thank you, and yes, question time.
Thank you. Do you have any questions?
You told that you had a Ruby monolith, then you decided to split it into microservices.
Yes.
What came first, need for microservices or tool, the Go? Or you check other tools, do you compare it? Why Go?
Oh, okay. So actually, we are not writing everything in Go. Actually, Go is used in very specialized sector where we need very predictable services. We need to do certain job. Like, I don't know, imagine parsing media is very easy to do with Go. So Go was considered, for example, by my team because it was easy to learn. All the people in my team, they learned Go in a bunch of weeks, and after a bunch of months, they were really proficient with it, and they were able to build very reliable software. Does that answer your question?
Yeah, thank you.
Lucien. Okay, thank you for your speech. I have a question about your version of Go compiler in production, how version you used. And have you any benchmark for checking profit of new version Go, for checking profit of for checking how estimate you use for new version of Go for your task?
So this is a very good question, and I'm really sorry because I actually forgot because I had these exact things. At some point in time, we had a problem with encryption. It was too slow for certain things, and we started using OpenSSL building a C binding. And what we did is that we measured the performance, and we had 60% faster, better latencies using C. But then every new release of Go, we wanted to check, have they increased the performance of their encryption library? And actually the answer is yes. I can tell you that in the next version, which was I think Go 1.5, we noticed that it was 12% faster. And then we measured up to Go 1. What is the last one? Go 1.6? The last one is Go 1.7, up to 1.6, and we noticed not much increase, but and now we are not measuring it anymore, but I suspect there will always be better code for that aspect. And for other aspect, really, it's working fine as is now. We don't, for example, do this for HTTP requests. Would be actually interesting, but we're not doing it.
Thank you for your talk. Do you have any problems migrating from one version of Go to another?
Yes, not my team, but someone was trying to build a very small container to build Go with Alpine, and Alpine use a different C library. It's not use this libmusl. And there were some problem with networking, like because I don't remember exactly, but it have to do with DNS resolution. So yes, sometimes there are, but in this year we have been pretty confident in adopting a new release quite fast.
Hello, thank you for the speech. Can you please explain, as a minus of microservices, you talk about versions. It was about versions of API. I understand it correct?
In this case, it was about dependencies. The thing is that you don't have one app to update now. You have to update many apps. And in Go, for example, since we froze our dependency in the vendor folder, so this means that if you update, for example, MySQL because there is a critical bug, you have to go through all your repository, update the vendor, retest it. It can be intense.
Okay.
I don't have much experience doing this in other languages, but in Go at least it's quite kind of painful.
I understand. Thank you.
More questions, guys?
Do you have in SoundCloud Golang for task of machine learning, data science?
Sorry?
For data science, machine learning, do you have Golang?
Do we have Golang? Oh yes. Well, so other team that use this that use Golang is the I think the search and recommendation team. I don't know if we use it for machine learning. I suspect we don't, and I don't even know. No, we don't use it. I think for data science, we use it for processing very big amount of information, like our distributed log processor is in Go, but I don't think it's being used for data science. I think there are very specific reasons. Maybe later it's proper time to ask at the specialist part.
Thank you for the speech. What was the biggest challenge for your company in migration to microservices architecture?
So I was not there when this started, so I can tell you what people complain about during lunch time, and also there is a recent blog article about it. So I think that the biggest change is the mentality. You are working on a new feature, you have to think, okay, this has to be in its own microservice. So you have to design. It would be one microservice, more microservice, Then there is the infrastructure aspect of it. You will not, maybe you want to move some data from the MySQL database to something else. You want to maybe you want to use Cassandra because it's better for the task. And then there is the thing that you always have to really try to remove things from the monolith. And actually, I think I can say that we failed in that because the monolith is still there. So it's not over. We just need to accept the fact that this thing can take a massive amount of time. So I will say that yes. So the big change is this understanding of domain-driven design. One feature, and.
The last question. Sorry, guys. Thank you, Andrea, for your speech. On some slides, I saw some rules of Prometheus and using Go code to call the rules, to generate maybe the rules. Did you publish something in open source, maybe the rules?
I think that Prometheus include, for example, the alert manager, which is what interpret alert and send them, but also everything I show about Prometheus is open source. So Prometheus itself, it's the rules are part of the Prometheus server component. So you will have to define them. In the example we have seen is how to use the Prometheus Golang client, which is still part of the of Prometheus, is maintained by the same team. I think that the Java bindings and the Go one are provided by the Prometheus team, and then there are many other which are open source.
Okay, can we find that? Maybe in open source that scripts and rules. Maybe you publish somewhere.
What do you mean, all rules?
I mean Prometheus rules for your services and.
Okay. Sorry, I am. Well, I don't think we can consider doing a talk in the future where we maybe talk what is important for us and what is not when we do rules and when we measure. For my team, I mean, we do HTTP, MQP, so knowing how many requests are being sent, being able to break down the latency by, DNS resolution, time to first byte, and so on. These are very important, and also the number of errors and so on. But you can check the blog because in the Java part of the organization, in the Scala, they are very active into explaining also this aspect. Maybe you will find some example of Prometheus rules.